Okay, so our objective today is to understand scatterplots. And there's two components to understanding scatterplots. Component one, we need to understand how to construct them. And then we also need to know how to interpret. So that's what we're going to be working on. And this is now lesson 1 on statistics. So we're going to be getting several packets. We're not going to do the lesson 2 from the new book. We're going to actually go and get information from our old algebra book because it actually has, I think, a better way to approach it with you guys. But one of the things you guys all wanted to do on your homework was to connect the dots because you were so used to doing that. But this is not graphing a linear function. This is graphing individual points. So we leave them as individual points. But there will come a point where we want to figure out, well, what line would best represent the relationship those dots tell us about. And then that's what we'll talk about in the second lesson. So first thing we need to understand is a couple vocab words, one of which is bivariate data. I know, it's a big mouthful. Shh. Well, if you don't understand the vocabulary, then it's hard for you to be able to interpret directions, right?
Yes.
Okay. So what is a bivariate? Well, bi means two, variate is a version of variables. So it's information with two variables, so two unknowns. So it's data with two variables, or a pair of numerical observations. So let's tack it back to the two homework problems you did last night. In the two homework problems you did last night, the first one was asking you to look at information that dealt with Celsius temperatures and Fahrenheit temperatures. So that would be considered your bivariate data. So Celsius temps versus Fahrenheit temps. Okay, so we were given pairs of information that connected a Celsius temperature with a Fahrenheit temperature. And then the second one you did dealt with the weight of an alligator. So an alligator's weight versus age in weeks. So the two variables was weight and time in weeks, and they gave it to us as numbers that paired up together. This particular week, this particular weight. Okay, so that's what this was all about. So that's what we mean by bivariate data. So bi to variate is variable. So it's information that comes from two variables. Katie, you writing? Okay. Anthony, we're taking notes, and your job is to write things down. So you're already behind. Okay, so then let's define a scatterplot. So a scatter plot, it shows the relationship between bivariate data, graphed as ordered pairs. on a coordinate plane. Now, so far, all of the scatter plots that we've dealt with deal with two positive things. I'm not sure I've seen a scatter plot with the negative things, so chances are we're only going to be looking at the first quadrant of the coordinate plane. But we got to remember, do not connect the points. Okay, so that's the important thing, is we don't connect the points, okay? Hopefully we got that after this one. So you guys had the two that you did? Oh, sorry. Do not connect the points. All right, so drawing a scatter plot is not the end. The scatter plot is just the beginning, and often what's happening is they're trying to figure out if there's some relationship between those two items. So what I'm going to do is draw some pictures, and there's two ways that we look at, is the data related to each other? Is there some significance between a Celsius temperature and a Fahrenheit temperature? Is there some sort of relationship between how old an alligator is and how much he weighs? Those are the kinds of things that they're looking for. So the first type of relationship that could exist is called a variable association. When I plot the two variable information, is there some relationship that exists? So I'm going to draw 3 diagrams, and we're going to go back and label them. So there's no real exactness in what I'm about to do, so you can just kind of get the same gist. So again, when we have a scatter plot, we just are plotting dots. Okay. So that's my first one. Here's my second one. And I'm not super good with making dots. And here's my third one. Now, in this particular book, they use the word association. So is there an association that takes place between what's on the x-axis and what's on the y-axis? In the algebra book, they use the word correlation, and that's the word that I have used more when it comes to studying statistics. Is there a correlation? So here's what you're visualizing. If I were to draw a line that best represents the first graph, so it would go down somewhat through the center of those dots, and it best represents. I have as many dots above it as below it. They're equidistant from that blue line I've just drawn. And what I notice is as the x value increases, so does the y value. So both of them are headed in the same direction. Now, thinking back to when we were graphing linear functions, what kind of slope does that blue line represent? A positive. So this is considered a positive association or a positive correlation. So when your points that you're when your points that you're graphing are heading in like a positive direction, like a positive slope direction, then we consider that a positive association. Okay. So the next one, if I try to draw a line that best represented, it would look like this. And in this one, as the x increases, what's happening to the y values? Yeah, the y values decrease. So they're not going in the same direction. One's going up and one's going down at the same time. So if you look at that line that kind of represents the direction that those points are going, what would that slope be? Okay, so what's is a negative slope? Okay, well there we are. So we would consider this to be a negative association or a negative correlation. Oops, there I go with correlation. Now the next one, there's not a line that I could draw that would best represent that data because it's really scattered all over the place. So basically what we say that there's no variable association. There's no association. There's no correlation. No variable association. The two variables are not linked to each other. Okay. Now, when we did the one yesterday of your arm span and your height, as people got taller, their arm span got larger because we ended up having a very positive correlation. Now, at the same time, Jonah was what we would call an outlier because Jonah was all alone. But what was interesting with you guys is you formed two clumps. Okay, and second period or fourth period, their graph didn't look like yours, and there was nobody that stood out. What was even more interesting about fourth period is they had 4 people whose height and arm span were exactly the same. So we had 4 perfect squares in that class. Okay, so that's one type of association. Now there's a second type of association, and that's called a linear association. So it's looking at how like a line is your findings. So like the one we did with Celsius and Fahrenheit, it was exactly a line because there was a constant change. So we're going to talk about linear association. So how closely does the data represent a line? Or how closely does the data resemble a line? So I'm going to give you 2 pictures. Okay. So again, what I would do is try to see if I could, what kind of figure do these points both best represent? And what you can see is that they represent a line pattern, okay? So we would call, and they may not be perfect, but that's okay. So we would call this a linear association because it looks like they're forming a line. But this other one, it kind of looks like that, a weird S shape. And that's not a linear one, that's more of a curve, so we call that a non-linear association. When it most looks like a line, just like the one that we had right in front of. Justin.
When you draw a line to the linear one, are you trying to like average it out?
Yeah, when you're, the line, what we call the line of best fit, which we're going to study next week, it's basically the line that would go through the center of the dots. It would have an approximate equal number of dots above it and below it, as well as the distance of those dots would be equal above and equal below. Okay. So in addition to saying, hey, that's a positive association or a negative, or there's no association, you also can say you have a linear association or a nonlinear association. Okay. Now, we've got a couple other things that we can notice in a graph, so I'm going to go do one more graph. So what you might have is a group of points that kind of group up together, okay? They're just kind of there. And then you may have a scattering of points. And then you may have something that just is in its own field, okay? So we call this grouping here at the bottom, that's called a cluster, okay? So the cluster, it's a collection of points close together. And then this guy over here, all by himself, he's called an outlier. Yep, makes him very special. Don't call him a loser. And this is a point that stands apart from the other data. Okay, so an outlier is a point that stands apart from the other data. Well, there'd probably be a cluster. You mean if there could there be two outliers?
Yeah, next to each other.
Yeah, there could be. We're going to be talking about how to actually calculate, I think, an outlier in other lessons. Okay. So here's what I'd like you guys to do for right now. We're going to pause